Hello there. We have done part one of this question. The question is saying the sum of the roots of a given quadratic equation is minus 5, and the product of the roots of this same quadratic equation is 3. Part one of the question is saying what are the two roots of this quadratic equation, and a part two is what is the equation itself. Let's recap what we have done in the previous video, and we go on for the second part. Here we are given the sum of the two roots as r1 plus r2 is equal to minus 5. On a given parabola, we always have a line that divides the parabola into two equal parts. That vertical line is called a line of symmetry. Once we have a line of symmetry, we can have a horizontal line that connects the two roots of the quadratic equation. At the same time, it intersects with the line of symmetry. In that case, because the line of symmetry divides the given parabola into two equal parts, we will have equal distance from the intersection point to any one of the two roots, equal distance. So we take that fact. Then the center point of such an intersection between a horizontal line, in this case the x-axis, and the line of symmetry is the center of the two roots. From that fact, we have here the center minus 5 over 2. Then, once we have the center, we can say the center point plus a and the center point minus a are the two roots of the given quadratic equation. That is a fact we have done before. So these are the two roots of the given quadratic equation. If that is a fact, then we go back here. The product of these two roots, which is here, is 3, which is also given in the question, right? So if the product of these two roots is 3, by difference of two squares, we come up to the fact that the distance between the roots is the distance from the center point to any one of the two roots, actually. The value of a is root 13 divided by 2. This we have done it in the previous video. You can go back and have a look if you want more. Then if we have that distance, then the root is the center point plus the distance a and the center point minus the distance a. These are the two roots of the quadratic equation. If that is a fact, then from the general fact that x1 minus root 1, we can say x actually. We have only one variable x here. Okay. X minus root 1 multiplied by x minus root 2 gives us the equation of the quadratic equation. Okay, that's a fact. So we have been here up to here. One root is here, the other root is here. We need to multiply these two to get the equation. But do we really need to do all these steps to find the equation from the product and sum of the roots? That's key. That's a key point now we have to cover in this part. Okay, the product of the two roots, r1 times r2 is given as 3. The sum of the two roots, r1 plus r2, is given as minus 5. We can use a simultaneous equation approach here to find out what is r1, what is r2, if required. Again, do we really need to do that is another question which we are going to see. Okay. r1 times r2 is equal to 3, which implies r1 is equal to 3 divided by r2. Let's take one fact here. All right. Once we have this fact from equation 1, We go back to equation 2 and substitute equation 3 into equation 2. R1 plus R2 is equal to minus 5. Let's just replace R1 by 3 over R2 here. 3 divided by R2 plus R2 is equal to minus 5. Okay, here I have a denominator 1. Let's take a common denominator, R2 here. 3 plus R2 square is equal to minus 5, which implies 3 plus R2 square is equal to minus 5 R2, which implies I shift minus 5 R2 to the left side, R2 square plus 5 R2 plus 3 is equal to 0. I have one fact here for R2. Okay, now what is this thing? Is a question. Am I going to solve a quadratic equation again? That's one fact. All right, no, we are not going to do that. But let's see, by replacing equation 3 into equation 1, and what are we going to get from that? Equation 1, R1 times R2 is equal to 3. R1 times R2 is equal to 3. Okay, R1 is root 3 divided by, R1 is 3 divided by R2. So 3 divided by R2 dot R2 is equal to 3. This cancels out. 3 is equal to 3. We are not getting anything here. We are only getting a true statement. Okay, good. So what does it mean by R2 square plus 5 R2 plus 3 is equal to 0? That is a question. From here, we are going to have two roots again. When we consider this as a quadratic equation, we are going to have two roots. Then that means it will be having two roots. What are the characters of these two roots? Their product, R1 times R2 is 3, and R1 plus R2 is minus 5. The characters are all these. For this equation itself, the characters of the roots is going to be our original condition here. That means this is the equation itself. In place of R2, I can use other variable such as x, then x squared plus 5x plus 3 is equal to 0. I can write it this way. But this itself, R2 squared plus 5, R2 plus 3 is equal to 0 is the equation. So that is how we can simply get the equation of the quadratic equation from the given conditions. Thank you so much.